So the point of mathematical induction is to prove a statement for integers. And the way it's framed is we always have what's called a base case. That has to be established first. So in this case, the base case is if I only have one term on the left-hand side, so we're saying that n equals 1. So the left side is 1. And the right side is this supposed formula for adding up the first n integers, which would be 1 times 1 plus 1 over 2, which is, again, 1. So, great. We have established that is true for n equals 1. So then, taking it from there, we want to say that if P of n is the state, we want to say that P of k implies P of k plus 1, which means that if P of k is true, that it follows that P of k plus 1 is true. And that kind of starts a chain of events. That means that P of 1 will imply that P of 2 is true, which will in turn imply that P of 3 is true, which will basically encompass all of the integers. So how do we do that for this particular problem here? So we assume that going up to some, going up to some number k, that we have k times k plus 1 over 2. And this is called the inductive hypothesis. Okay, so I'm just going to write that down here too. Inductive hypothesis. So what we want to do is show that when I add the next term, that formula still follows based on knowing this. So this is the key step right here. We have to use this in order to prove the next steps. So here's what we do. We're going to write 1 plus 2 plus many more plus k is equal to. Now, part of the success in proving by induction is knowing what you're going toward. So basically, if I replace k with k plus 1, the goal is to get k plus 1 times k plus 2 over 2 on the right-hand side. So I'm going to add the k plus 1 here, and then using the fact that we know in the box, can we arrive at the conclusion? So that means all of this gets replaced with k times k plus 1 over 2, and then plus k plus 1. So we're hoping that algebraically it's equivalent to that goal over there. So what I'm going to do, I'm going to make a common denominator. So I'm going to say this is k times k plus 1 plus 2 times k plus 1 all over 2. And look at that. I can factor out a k plus 1 in the numerator. And I'm left with k plus 2, and that's all over 2. And hey, that's the goal. So therefore, adding up the numbers 1 through n does indeed follow this formula. Because again, it's true for n equals 1, which means it's true for n equals 2, and n equals 3, and n equals 4, and so on and so on. So this is your first basic proof by induction. Hopefully it helps. Thanks for watching, and look out for more.